Welcome to the third session of quadrilateral. Now let us discuss one problem regarding the quadrilateral. The problem is ABCD is a parallelogram. ABCD is a parallelogram and E is the midpoint. E is the midpoint of side BC. DE and AB on producing meet at F. Prove that AF is equal to 2AB. What you can do is that you can try it yourself, and after that you can look at this solution. Now, first of all, whenever you are solving the problem of quadrilateral, just remember that you should first draw the figure. It is given that ABCD is parallelogram. So first draw a parallelogram. This is a parallelogram ABCD. And E is the midpoint of side BC. This is side BC and E, this one, this is the midpoint of side BC. DE and AB on producing meet at F. DE and AB on producing meet at F. So let's produce this side DE. Like this, and produce AB. They meet at F. This is point F. Now we have to prove that AF is equal to is equal to 2AB. AF is equal to AF, this one is equal to 2 twice of AB. That means B is the midpoint. B is the midpoint of AF. Now, how we will do this? We know that ABCD is a parallelogram and E is the midpoint of this. E is the midpoint of side BC. So that means this side is equal to this side, right? Now, this one, this angle, let this angle be 1. This is equal to this angle, this is 2. Because they are vertically opposite angles. And the third thing is this angle C. Let this be 3 and this be 4. So in triangle, DEC and triangle BEF. We take these two triangles, triangle DEC, this one, and triangle BEF, this one. We are given that E is the midpoint, so BE is equal to EC, angle 1 is equal to angle 2, vertically opposite angle. Similarly, BE is equal to EC because E is given the midpoint. Of BC. Then the third thing is angle 3 is equal to angle 4. How? Alternate angles. Therefore, the triangle DEC is congruent to triangle VEF by angle side angle, ASA rule. ASA rule. So when both these sides are both these triangles are congruent, therefore I'll complete it here itself. BF is equal to DC and we also know that DC is equal to AB, therefore BF is equal to AB, and if BF is equal to AB, therefore we can write AF as AB plus BF or AB plus AB, right? So therefore AF is equal to 2AB. Now one more problem I'll take. Question 2. We have to prove that the figure formed by joining the midpoints of the pairs of consecutive sides. Consecutive sides of a quadrilateral is a parallelogram. Prove that the figure formed by joining the midpoints of pairs of consecutive sides of a quadrilateral form a parallelogram. Now, let us draw the diagram for this. Let this be any quadrilateral and we name it like ABCD. Now the midpoints of all these sides is, this is E, F, G, H. Now join them. We have to prove that EFGH is a parallelogram. To prove EFGH is a parallelogram. Now how we'll do this? Let us see. Here we have to do a construction. Just join A to C. Join A to C Then in triangle ADC, in triangle ADC, this one, ADC, we know that H is the midpoint of AD and G is the midpoint of CD. Then by midpoint theorem, GH is half of AC and GH is parallel to AC. H and G are the midpoints of AD and CD respectively. Therefore, HG is parallel to AC and is half of AC. This is by midpoint theorem. Similarly, in triangle ABC, in triangle ABC, EF is half of AC and EF is parallel to AC. That means HG is half of AC and similarly EF is also half of AC. Therefore, HG is equal to EF. And we know that HG, AC are parallel and AC and EF are also parallel. Therefore, EFGH is a parallelogram because one pair of opposite sides EF and HG, EF and HG, this one, they are equal and parallel. Therefore, EFHG is a parallelogram. Thank you for now. Tomorrow we will be taking some more problems. Until then, good night.